Stateful DHCPv6 is a dynamic configuration. It works in a similar way to DHCP for IPv4 except that the default router is learned by the Neighbor Discovery Protocol, NDP. This is a new IPv6 protocol. Stateful DHCPv6 uses multicast address FF02:1:2. It is stateful. It keeps information about its clients such as addresses and lease times. To configure it on the interface, enter IPv6 address DHCP. In the next slide, let us learn stateless address auto-configuration. Slack is also a type of dynamic configuration. The domain name server, DNS server, is provided by DHCPv6, but NDP provides the prefix, prefix length, and default router through router solicitation, RS, and router advertisement, RA, messages. To use Slack, at least one router must be configured for IPv6 routing and have an IPv6 address. On the local router interface, manually configure the IPv6 address, then enter the command IPv6 address autoconfig default. On the other interfaces of the router and on the other local nodes, either create only a link local address with IPv6 enable, or have both a link local and global unicast automatically generated with the IPv6 address autoconfig command. Take some time to look at the configuration and syntax. We discussed addressing options in detail. In the next slide, let us focus on static routes. In IPv6, there are three ways to configure static routes. With directly attached static routes, only the output interface is specified. Fully specified static routes are used when the output interface is multi-access. Both the interface and next hop are configured. Note that the interface comes before the next hop as compared with IPv4. In recursive static routes, only the next hop is specified. This example specifies that all destinations with address prefix 2001:db8:32 are reachable via the host with address 2001:db8:3000:1. Take some time to study the commands on this slide. When testing routing in IPv4, the ping and traceroute commands are used extensively. What about in IPv6? Let us understand this in the next slide. The ping and traceroute commands accept either an IPv4 or an IPv6 address. The output from pinging an IPv6 address is displayed on the slide. This looks very similar to pinging an IPv4 address. However, to ping a link local address, the interface must be specified. To do this, use an extended ping. Let us discuss this in the next slide. Enter the ping command without any parameters. You will be prompted for more input. The first prompt asks for the protocol. The default is in brackets. The default is IP, which means IPv4. Enter IPv6. When prompted, enter the IPv6 address. There are other prompts which will be omitted. For output interface, the entry S0/0/1 doesn't seem to work. The error message says to enter the full interface name. It looks like the input serial 0/0/1 works. Note that the output then says the packet was sent with the address, then a %, then the interface. And the ping works. Take some time to review the output on this slide. Let us discuss transition strategies in the next slide. Transitioning to IPv6 is inevitable. However, there is a huge IPv4 infrastructure at present. Not all can be converted at once. The overall goal is to transition all processing to IPv6. While this happens, you must be able to route from one IPv6 island to another. There are three methods to transition from IPv4 to IPv6: dual stack, translation using NAT-PT, and tunneling. Let us look at each method in the following slide. A protocol stack is a series of compatible protocols used at different layers of the OSI model. For example, Ethernet with IPv4 and TCP is a protocol stack. The protocol stack that includes IPv6 is, of course, not the same. In fact, it is incompatible. So a dual stack device is needed, a device that can handle both the stack containing IPv4 and the stack containing IPv6. Cisco iOS release 12.2.2t, and later, with the appropriate feature set, can handle both IPv4 and IPv6 routing simultaneously. When both IPv4 and IPv6 are configured on an interface, the interface is considered dual-stacked. The second IPv6 transition method is Network Address Translation, Protocol Translation, NAT-PT. It replaces an IPv4 header with an IPv6 header and vice versa. This approach has two disadvantages. It causes a loss of header information and processing is slow. In the following slide, let us look into the next transition strategy, tunneling. The third IPv6 transition method is tunneling. Tunnels are virtual interfaces. They are similar to the switched virtual interfaces, SVIs, that are used in switches. Tunneling can be used to connect islands of IPv6 over an IPv4 network, as shown on the image. A tunnel is configured to allow IPv6 traffic to pass between the IPv6 island on the left to the one on the right. Tunnel management occurs at the tunnel endpoints. The tunnel endpoints, which are the routers in the figure, are dual-stacked. An endpoint can be a physical interface or a loopback. The endpoints encapsulate the IPv6 information inside of an IP4 packet, or vice versa. In the next slide, let us discuss different types of tunnels. An intra-site automatic tunnel addressing protocol, ISATAP tunnel, just as its name implies, can be used only within a site. ISATAP tunnels have three advantages. They support global unicast addresses for all prefixes. IPv6 addresses are dynamically assigned. In many other types of tunnels, IPv6 tunnels must be manually configured. ISATAP tunneling is available in most Windows and Linux operating systems. Another type of tunneling is Teredo tunneling. This encapsulates IPv6 packets in IPv4 UDP datagrams to tunnel through an IPv4 network. We have discussed different types of tunnels. Let us discuss its issues in the next slide. Tunnels increase the overhead in each packet. The same amount of data now has an IPv4 header and an IPv6 header. They can cause maximum transmission unit MTU issues. Because the packet is bigger, it can go beyond interface limits on packet size. In addition, troubleshooting is more difficult. This is because there is even more encapsulation than normal. Let us move on to the quiz questions to check your understanding of the topics covered in this lesson.